So if you see, what is it saying? Variable and value heuristics. So far, we have selected the next variable and the next value by using a fixed order. Okay, for so that it is easy to visualize the algorithm, how it performs, and all these things. But the point is, in this for this problem, we can actually get little more benefit if we are more flexible. Hello, hello. Please keep your mic. Uh, please keep your microphone mute. Okay. So now, so what I'm saying is, if we are a little flexible in choosing the order of the variable and choosing the values, choosing the values from a hello, Ritayan Dash, can you please? Kamlesh Rai, can you please switch on your mic? Yes. Okay, so I muted him anyway. There are other people whose mic is not muted, but they are not causing any problem. So most probably they are connected through hands-free mode. So okay, great. Now, so what I was saying is there a better way to pick the next variable? Also, is there a better way to select the next value to assign to the current variable? And the answer is yes. I mean, it matters on the fly which order you choose the values and in which order you choose the variables. Okay, so I can give some reasonings based on some examples. On the basis of some examples, how it is the decision to choose one variable before the other can make a difference in pruning the tree and thereby getting the solution fast. Okay, so it is possible, and more importantly, it also matters how, what order I choose the value. Okay, so that's what I will show you in with a few examples in the next slides. Okay, so if you see, there is a concept of most constraining variable. Selecting a variable which contributes to the largest number of constraints will have the largest effect on the other variables. Okay, so did you hear what I said? Selecting a variable which contributes to the largest number of constraints will have the largest effect on the other variables, and hopefully will prune a larger part of the search. So please understand the general philosophy. The general philosophy is, whenever I assign a color to a particular vertex, that means I assign a value to a particular variable. It goes ahead and in turn produces many more constraints on the other variables. Like, this variable cannot get this color, that variable cannot get this color, like that. Okay. Now, the point is, obviously, in whatever order I suppose I ultimately I color V1 as red, V2 as magenta, V3 as blue, V4 as black, and whatever. Now, in any order I colored them, if I assign the same colors, then the constraints are going to be exactly same. But it is important to know as many constraints as early as possible. Okay, like when you are a kid and when you grow up and when you become a college goer, there are certain things you learn through your experience, that these are possible and these are not, these are possible and these are not. The more you learn what is not possible in life, the earlier you learn, it actually helps you to take decisions which ultimately do not lead to chaos, or which ultimately do not lead to wastage of effort. Okay, So you get the idea what I am saying. So it is the same thing. Selecting a variable which contributes to the largest number of constraints will have the largest effect on the other variables. Hopefully, will prune a larger part of the search. This amounts to finding the variable that is connected to the largest number of variables in the constraint graph. So if I said V1 is equal to R, if you have a look, setting variable V5 will affect 4 variables because it is connected to 4 other variables V2, V7, V6 and V4. But setting variable V2, V3 or V4 affects fewer variables, maybe 2 or 3. Okay. I mean, now that V1 is connected, if I now try to color V2, it will only pose a constraint on V5. Okay. Now that V1 is connected, if I try to color V4, it will only try to pose a constraint on V5 and V3. But if I color V5, it is simultaneously going to affect all these colors, all these variables, V2, V7, V6, and V4. Hence, the best thing is to try to color V5 first and get as many constraints and as early as possible. This is what it is saying. Now let's see what is happening. It is saying minimum remaining values. Now, so selecting the variable that has the least number of candidate values is most likely to cause a failure early. So this is another strategy, minimum remaining values. So selecting the variable that has the least number of candidate values is most likely to cause a failure early. Now look at this condition of the graph. I have colored V1 with red and V2 with blue. Okay. And now see the crosses. Because of the constraint from V1, V3, V4 and V5 cannot have red color. Okay. Cannot have red color. And because of V2 being colored blue, V5 and V7 was also made crossed with blue color, and then we assigned red color to V7. Okay, and what did it do? It made that V3 and V5 cannot have red color. Now look at the whole scenario. Those who are colored, they are colored, that's fine. But those who are not colored, out of them, V5 has the least number of remaining values. So here also, V5 is the most constrained variable and is the most likely to prune the search tree. Okay, so so I'm sorry. So V5 being the most connected one and will affect most other variables is not under this heading. It was already covered earlier. Here, by most constraining variable, we meant this what I right now said, that once I look at the checkerboard under this condition, V3 has 2 colors left, V4 has 2 colors left, V6 has 3 colors left, but V5 has only 1 color left. So V5 is the most constrained variable, and I will better go and color it immediately. Now I don't have any other choice. So I will put V6, V5 to green anyway and see what all other variables now get more constraint, because as soon as I make V5 as green, then V6, from V6 the green color option will go away. From V4 the green color option will go away, and that will further restrain those variables, and that is a correct strategy to color the minimum constraining value first. Okay, sorry, most constrained variable first, or rather minimum remaining value variable first. Okay, so the last one, I mean, this is already I said, least constraining value. Choose the value which causes the smallest reduction in the number of available values for the remaining variables. Now this Okay. Now the least constraining value, choose the value which causes the smallest reduction in the number of available values for the neighboring variables. So suppose we want to color V3 under this condition, means V1 and V2, they are colored and they have posed certain restrictions on the other variables. For clarity, we didn't show that here. And next, give me a second, okay? Okay, so under this condition, V1 and V2 are already colored, and we want to next color V3. Okay, now obviously V3 has an option of getting colored by any of the colors except red. Okay, except red, because V3 is connected to V2. So I can try, I can try uh, green, blue, or yellow. Okay, green, blue, or yellow. Now the point is, what is it saying? Now, if I color blue, then there will be a restriction on V4 that V4 cannot have green, cannot have red, cannot have blue. Okay, and the only choice that will be left for V4 will be yellow. Think about this: red, green, red, and blue. So V4 have only choice left is yellow. The same thing will happen if I color V3 with yellow. Okay, V4 will have only one choice left, which will be blue. But if I color V3 with green, then for V4, two more choices will be left, which will be blue and yellow, and that will further keep more choices for that might keep more choices for the other variables. Here it doesn't matter in this example, but it might remain. So choose the value which causes the smallest reduction in the number of available values for the neighboring variables. So that's why, yeah.
স্যার বলছি ভিটিটা যখন আমি গ্রিন কালার করব, তো স্যার ভিপোরটা দুটো চয়েস মানে ব্লু ইয়েলো, স্যার রেড কেন করতে পারবো না ভিপোরটা?
এই তো V2 টা কানেক্টেড আছে না রেডে, V2 টা রেডের সাথে কানেক্টেড আছে তো।
তো দুটো অপশন করে যাচ্ছে ব্লু আর ইয়েলো।
মানে V2 টা তো রেডের সাথে কানেক্টেড আছে, দেখতে পাচ্ছিস তো?
হ্যাঁ স্যার, হ্যাঁ স্যার, বুঝেছি।
Okay, okay. So that was the last strategy. Now what I did not do is I did not put all the strategies together, but I have taught you all the strategies, and what you can do is you can code them separately, all these strategies, and then run on your graph and see what is happening. Okay, and you will then come to be able, then you'll then be able to decide yourself in what order to play all these constraints, rather not constraints, all these strategies, to get the best solution in minimum time. Okay, there is nothing best solution. The solution here is only colorability. So by best solution I mean i want to traverse as less as possible through the graph, or as less as possible I want to work in assigning colors and then pruning trees and all these things. Okay, so so that is it. I hope all of you understood all the strategies separately, and now keep them all coded as strategy 1, strategy 2, strategy 3, strategy 4, and then take it as an assignment to decide in which order you are going to apply the strategies. Okay, so all the possible strategies, AI strategies, have been taught to you. Okay, now next we take another example and we solve the backtracking 4 queens problem. Now this is an old problem which you probably learned in data structure or algorithms as a part of the recursion class. So you already know how it works. Only thing is what we are going to do. Only thing is what we are going to do is we are going to formulate it in terms of AI jargon, okay? So that you can code it as an AI problem. Now, some of these things we have already discussed on the first day or the day before of constant satisfaction, where we had actually my god. Okay, so give me a sec. Hello. শব্দ করবে না হ্যাঁ ওকে সো ঠিক আছে ওকে ওকে সো হ্যাভ আ লুক কি কোনটা ওই দিকটা মাই গড okay, there's some masons working in my house, so they are making some demand suddenly. Okay, so variables qi associated with each row of 4x4 board. Now what are qi? So we already said that we know that all these queens have to be in separate rows and separate columns. So one thing, we by default assume that all these queens will be in separate rows, and qi stands for the queen which is standing in the ith row, okay, and qi will give me the column number of that queen. Qi will give me the column number of the queen in the ith row, okay. Now what are the possible values for each qi? Obviously they can be in column 1 or column 2 or column 3 or column 4, okay, and that's why the domain of di is 1 2 3 and 4, okay. That's why the domain of di is 1 2 3 and 4. Now what are the constraints? We have already told about the constraints. Qi cannot be equal to qj, that means they cannot be in the same column. And the other which takes care of that they do not cancel each other being in the same diagonal is qi minus qj, or rather the modulus of qi minus qj is not equal to I minus j, or same diagonal. Can somebody tell me, did I explain this thing, this being in the diagonal, how this constraints takes care of that? Can somebody tell me please? Hello, is anybody listening?
I think yes, sir. I think.
Okay, so I will straight away go into I think then you understand what is the meaning of this constraint, and then I will straight away go to this example how the backtracking is proceeding. This also I actually told, but I'm still repeating that, okay, that's not a problem. Okay, so let's see what is happening. This guy, so somebody whose mic is on, can you please make sure you mute yourself before talking? Okay, so let's still going on. Okay, so this is the 4x4 checkboard, and I mean all of you understand this, but still one last time I am showing you how the moves are proceeding. Okay, so we start with the first queen, means the row 1 queen being in first column. So the first queen is here. The moment the first queen is here, I cannot put the second row queen here, I cannot put it here, but I can put it here. Okay, so I do that. Now what about the third queen? It cannot be here, it cannot be here, it cannot be here, it cannot be here because of the diagonal, it cannot be here because of straight as well as the diagonal, it cannot be here. So q1 equal to 1, q2 is equal to 3. So q2 equal to 3 because it is third column. I mean, if you want, I can write the column numbers also here. So 1, then 2. Okay, so that will make it very clear. So and then q2 is equal to 3. Now q3 has no possible value, so we have to backtrack and go back and put q3 in the, sorry, q2 is equal to 3, and then I have to put the second row queen in the fourth column. Okay, so we move that. Okay, so we move that and we put here. Now what happens? q3 cannot be here, q3 can be here, right? Because it is not getting cancelled. Also q3 cannot be here because of this, q3 cannot be here because of this. So if I put q3 here, now look at q4. I cannot be here because of this, I cannot be here because of this, I cannot be here because of this, and I cannot be here because of this. So I have to again, after making q1 equal to 1, q2 equal to 4, q3 equal to 2, I have to still backtrack. And if I now backtrack, my q2 has reached the fourth position, tried out all these options, then I have no other option other than moving q1. Okay, because putting q1 in first column, I have checked that all options are removed. We cannot simply, it simply cannot give me any solution. Okay. What the hell is this? Anyway. So, that I cannot do, so I have to move this gun up. Now I can do this. Okay, so now let's try the next thing. I should try to put q1 here, the second position. So we put here. What about q2? It cannot be here, it cannot be here, it cannot be here, but it can be here. What about q3? It cannot be here, it cannot be here, it cannot be here, it cannot be here. Is that true? I don't know. Can it be here? Somebody tell me. Can it be here?
Yes, sir.
Yeah, because we are not getting cancelled by this one as well as this one. Okay. Now look at q4. It cannot be in first column, it cannot be in second column, it cannot be in fourth column. Only choice is third column, and the diagonals are this and this where there is no queen, and this one turns out to be a solution. Okay. This one turns out to be a solution. Good. Now let's stop annotation. Let's go to the, so q1 is 2, q2 is 4, q3 is 1, and q4 is 3. This is a possible solution. And obviously, you know, like there are many reflection solutions by reflection and solutions by rotation and all those things. But at least by backtracking, we found one solution. Okay. If you keep on doing the backtracking, you will be able to find all the solutions. There is no doubt about it, because this method is not going to miss any solution at all. Okay. So so that is the idea. And basically you could solve it by putting the, so let me clear this out. You could solve it by putting the constraints and periodically trying them out. Okay, you put all the constraints, and through a AI program in for loop you can try all of them out, and ultimately you are bound to get the solution if you write the tree searching properly, tree traversal properly. Now the last problem. This is a new problem for you, so I think you will be more interested. কোনটা আগেরটা? আমি তো ছবিটা সরিয়ে দিলাম রে।
স্যার ওই যে n কুইজ বা ওই যে 4 কুইজটা,
এই তো Q1 এ মানে সেকেন্ড Q1টা সেকেন্ড কলামে রাখলে Q2টা ফোর্থ কলামে রাখা যাবে, তারপরে Q3টা ফার্স্ট কলামে রাখা যাবে, আর Q4টা থার্ড কলামে রাখা যাবে। আমাকে আবার পুরো ছবিটা আঁকতে হবে, ঠিক আছে? তুই ঠিক এমন সময় বেরিয়ে গেছিলি।
আমার ল্যাপটপটা কি ব্ল্যাক আউট হয়ে গেছে।
বুঝতে পেরেছি আমি। প্রবলেমটা হচ্ছে যে আমি তো ছবিটা জাস্ট উড়িয়ে দিলাম, এখন আবার পুরো ছবিটা আঁকতে গেলে না দেরি
ঠিক
হয়ে
আছে
যাবে।
স্যার, ঠিক আছে।
আই থিংক আমি এটা আগেও এক্সপ্লেইন করেছিলাম। হ্যাঁ, মানে আচ্ছা আমি তোকে এইখানটা এঁকে দেখিয়ে দিচ্ছি, তুই এইটার উপর একটু কনসেন্ট্রেট কর, এর উপরেই এঁকে দেখিয়ে দিচ্ছি। দেখ, অ্যানোটেট, আমি এগুলো উড়িয়ে দেবো, তারপরে ভালো করে দেখ। যদি ফার্স্ট কুইনটা তোর এই ফার্স্ট রোর কুইনটা যদি সেকেন্ড কলামে থাকে, তাহলে সেকেন্ড রোর কুইনটা এই কলামে থাকতে পারবে, কোনো অসুবিধা নেই। কারণ এইখানে কুইনটা থাকার জন্য কি হবে, ডায়াগোনালি এখানে হবে না, এইখানে হবে না, এইখানে হবে না, তাহলে এইখানে হবে।
ডায়াগোনালি রিলেশন কিছু হবে না।
না, তুই দাবা খেলেছিস তো? না, দাবা খেলিসনি কখনো?
হ্যাঁ স্যার খেলেছি।
হ্যাঁ, তাহলে এইবার থার্ড, মানে এগুলো সবই হচ্ছে রানী, কুইন, ওকে? সো ও পাশাপাশি কাউকে বসতে দেবে না, কেটে দেবে। সোজাসুজি কাউকে বসতে দেবে না, কেটে দেবে। আর ডায়াগোনালিও কাউকে বসতে দেবে না, কেটে দেবে, ঠিক আছে? কিন্তু এই কুইনটা কোথায় বসে আছে? ওর ডায়াগোনালেও কিন্তু বসে নেই, তাই জন্যই বেঁচে গেল, ঠিক আছে? এবারে থার্ড রোর কুইনটা ক্যান বি ইন দা ফার্স্ট কলাম। তাহলে দেখ, এই কলামে কোনো কুইন নেই, এই ডায়াগোনালে মানে এই পজিশন গুলো লক্ষ্য কর, এই ডায়াগোনাল পজিশনে কোনো কুইন নেই, ঠিক আছে? তাহলে এইখানে ও বসতে পারবে। আর ফোর্থ রোর কুইনটা তোর বসতে পারবে হচ্ছে এইখানটায়। দেখ, হ্যাঁ, এর কলামে কেউ নেই, এর ডায়াগোনালটা হচ্ছে এইখানে, এইখানে, এই দুটোতে কেউ নেই, আর এই ডায়াগোনালটা হচ্ছে এইখানে, তাহলে এখানেও কেউ নেই, বুঝেছিস? সেই জন্যই ফার্স্ট রোতে Q1 ইকুয়াল টু 2, তার মানে কলাম নাম্বারটা 2, Q2 ইজ ইকুয়াল টু 4, মানে কলাম নাম্বারটা 4, দেখ, Q3 ইজ ইকুয়াল টু 1, কারণ কলাম নাম্বারটা হচ্ছে 1, আর Q4 ইজ ইকুয়াল টু 3, কারণ কলাম নাম্বারটা হচ্ছে 3। বুঝতে পারলি?
হ্যাঁ স্যার। স্যার এটা কি আমি রিকারশনে যে n কুইন প্রবলেম করেছিলাম ওটা কোনো কি?
হ্যাঁ হ্যাঁ, ওইটারই ছোট ভার্সন একে দেখানো হচ্ছে। ইউ ক্যান সলভ দিস ফর 8x8 চেস বোর্ড ইউজিং দ্য সেম অ্যালগরিদম, ওকে? You can solve the eight queens problem by the same algorithm, no problem, okay? Okay, চল এবারে না এগোলে আমরা আজকেও শেষ করতে পারবো না। হ্যাঁ, okay, now see, we are going to solve this crossword problem. Okay, again, this is a typical AI problem, and you are not familiar with this problem, but it is an easy one. So what is it saying? There is a crossword for words given, okay? And if you have a look, there are several, so these are the words that are possible. So in case of your normal crosswords that come in the paper or in the magazines, there is some clue, some phrase is given or some sentences are given from where you have to decode the meaning and solve the crossword. Here the strategy is different. There is a pool of words being given, pool of words, and these words can and your solution can only come from these 15 words. There are 15 words, you see, 6 plus 6 12 plus 3 15, okay? Now how will you use them judiciously? So look, there are eight clues, 1 across, 4 across, 7 across, and 8 across, and there are downwise, there are 4, 2 down, 3 down, 5 down, and 6 down, okay? So if you have a look in the next slide, you will see this is the funda. The variables are 1 across, 4 across, 7 across, 8 across, and the other 4 variables are 2 down, 3 down, 5 down, and 6 down, and the starting cells are 1 4 7 8 2 3 5 6, which are obvious. Now the point is, we have calculated the domain for each of these variables. Domain means what all values it can take. Now, how did we come up with this domain? Look, the reason is the one across clue, it has to have 5 letters in the word, right? 1, 2, 3, 4, 5. Likewise, 2, 1, 2, 3, 4, 5. 3, 1, 2, 3, 4, 5. 4, it can take 4 values, 1, 2, 3, 4. 5, 4, 1, 2, 3, 4. 6, it can take 3 letter words, 1, 2, 3. 7, it can take 3 letter words, 1, 2, 3. And 8, it can take 5 letter words, 1, 2, 3, 4, 5. So likewise, we formed the domain. So, yeah. তো ক্রসওয়ার্ড তো তুই জানিস না, দেখ এইখানটায় যদি ব্লক থাকে এটা তো ডাউন হতে পারে না, ইট হ্যাজ টু বি অ্যাক্রস। হ্যাঁ, তুই ক্রসওয়ার্ড করেছিস তো ছোটবেলায়। যেহেতু যেহেতু 6টা ডাউন হচ্ছে, 8 কখনো ডাউন হবে না, কারণ 8টা তো সাবস্ট্রিং হয়ে যাবে না। ঠিক আছে, ওকে। তো দেখ এবারে okay, so anyway, that was a common question I faced in yesterday's class also. I mean, it appears in the mind, but the idea is 7 can be only across because 7 is a part of 2 down, so it will never be down. Okay, good. 5 is a part of 4 across, so 5 cannot be across, 5 is down. Okay, good. Now see, so we reduced our problem to this domain. So these variables 1, 8, 2, 3, they have 5 letter words. So we have, what did we do? We found all the words which have 5 letters. There are 5 in number here: horses, laser, sheet, steer, and sails. So we have kept them in the domain for each of these clues where 5 letters are needed. Likewise, for these number 4 and number 5, we have kept all the 4 letter words. They are 5 in number. And likewise for 7 and 6, we have kept the 3 letter words. Now, is that all? No, there are some constraints, and you must have already understood the constraints. What are they? The third letter of the first word, one across word, must be the first letter of the 2 down. The fifth letter of 1 across must be the first letter of 3 down. You get it? So that's what. Also, I have formed a graph here. It's called constraint graph for this problem. Now, when you grow up in computer science, you will see that this constraint graph is a very common technique that we employ in various fields, especially in VLSI or hardware algorithms, or especially in electronic design automation. But not only there, in social networking, everywhere we have constraint graphs. Okay, so we have the entities being represented as vertices and any constraints that are represented on the edges of the graph. Okay? Now why did we connect these by edges? Look, 1A is connected with 2D and 3D, not to anybody else. Why? Because look at the crossword. 1A, 1 across, decides what should be the first letter of 2 down and 3 down, but not of anybody else. So I have kept 2 links, 1A to 2D and 1A to 3D, and on these 2 I have written the constraints. 1A3 is equal to 2D1, means third character of 1A is same as second character of 2D. Fifth character of 1A is same as first character of 3D. Likewise, we can take another example. Let's go to 2D. So 2 down is this, and with whom does it interact? It interacts with 4 across, it interacts with 7 across, and it interacts with 8 across. And what are the constraints? letter of 2 down is equal to the second letter of 4 across. 4 starts from here, so the second letter should be same. Fourth letter of 2 down must be the first letter of 7 across. Fifth letter of 2 down must be the third letter of 8 across. So look, I have written, I think, one of them. Third letter of 2D must be same as the second letter of 4 across. Likewise, I have written one more constraint on here, 2D and 4HA. 2D and 8A, remember? So what is there? 2D and 8A. Fifth letter of 2D must be third letter of 8 across. Okay, all of you are convinced? Fifth letter 1, 2, 3, 4, 5. The fifth letter of 2D must be same as third letter of 8 across. Okay, so fifth letter of 2D is equal to third letter of 8 across. Likewise, how many constraints are there? You can count the number of edges. You can count the number of edges: 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 9, 10, 11, 12. So you are going to have 12 constraints, and if you write the constraints, all these edges, and if we periodically use these constraints to solve the problem, then we will get the solution. The CR, please give the please click the attendance if you haven't done yet. Okay, there were max 40 participants, because we are going to end in 1.5 minutes. If it ends, I will connect once more, but we have to still finish the class at 3, and this is the last slide anyway, so don't worry. But I'm not yet finished in saying what all I wanted to tell you about the procedure to solve, how to do this. So you go to 1A first, okay, and then you take just any one value from the domain. Okay, so let's say you put horses, or say take some other example. Let's say you put sales. Okay, if you put sales, SAILS, then what happens? The third letter is A3 is I, and it should be the first letter of D1. But unfortunately, there is no. So you go to 2D. Unfortunately, none of these words start with I. None of these 5 words. So sales is not an option at all, and I have to backtrack. Okay, sales is not an option for this word 1. So anybody waiting? Yeah. Okay, so I hope by now you have understood the thing. So if I put horses for 1 across, then A3 is S, and that will be equal to D1. So I have to then go and search in 2D which all words start with S. Now I have sales, sheet, steer. So I will pick any one of them and then go down the tree and go and try to check what all, then there is another constraint. So A5 is equal to 3D1. So again, what is A5? A5 is S, because horses, the fifth letter is S. Then for 3 down also I have to check. I have to choose a word which starts with S. And in this way, I keep on going down and checking. And whenever I get stuck, I don't have any choice of words for a particular variable. I have to backtrack and try out some other words. This is the whole idea. I think we are, what is the time? It's 2:59. So you have to leave. I think you have another class.
Yes, sir. Automata class.
Okay, so please go ahead and attend the class. And we are done with this chapter. When you come back after the Puja holidays, we have just 2 things left: AO star and iterative deepening of A star. And happy Puja, best of